Hello students, welcome back to RD Chemistry. Here I'll discuss electrode potential of third electrode using other two electrode reactions. And actually this is a continuation from the last video. So let us start now. The problem I'm going to solve is similar to that of this problem which I already discussed in the last video. If you have not watched, please do watch it. I'm going to continue with a little different problem. See the data given. E naught of Mn plus 2 to become permanganate minus 1.51. E naught of MnO2 to become Mn plus 2, it is a 1.23 volt. Now we have to calculate E naught of MnO4 minus to become MnO2, value to find out. Let us find out whether they have given oxidation potential or reduction potential. So here MnO4 minus the first data. If I calculate the oxidation number, it is equal to plus 7. Plus 2 becoming plus 7 is oxidation. Therefore, it is a oxidation potential. We'll have to change it. So what we'll do now? E naught. So manganese plus 7 in the MnO4 minus to become Mn plus 2, which will be equal to now plus 1.51 volt. So this is the reduction potential value. Next data you see here, MnO2. Here oxidation state of Mn is a plus 4. Plus 4 will become plus 2. So therefore it is a reduction reaction. Therefore this value is a reduction potential, right? So second data as it is, no change. E naught Mn plus 4 becoming a Mn plus 2. So its value is equal to 1.323 volt. Next one, last one we have to find out actually. Now, Mn plus 7 state in MnO4 minus becomes a plus 4 state. So this is a plus 7 becoming plus 4. So it's a reduction and the potential value is a reduction potential value, right? So third one, E naught of Mn plus 7 becoming Mn plus 4 reduction, and its voltage you have to find out. Okay, so we'll start with the highest oxidation state to become the lowest oxidation state. Okay, see the value, these are the values I'm going to make use of, not directly but in the form of delta G, that is the gas free energy chain. So I'll start with the maximum oxidation state. Mn plus 7 become Mn plus 2 lowest state. It has to gain 5 electrons. Okay, then next highest oxidation state is plus 4. Mn plus 7 should become Mn plus 4. For that it has to take 3 more electrons, and Mn plus 4 should become Mn plus 2. For that it has to take 2 electrons for reduction. Whether the reaction take place single step or in several steps, the gas free energy should remain the same, but we are not going to add up the voltages. Voltages are not additive quantities. So this is the delta G1 naught. So this is the delta G2 naught, and this is the delta G3 naught. Okay, so you have to find out for plus 7 becoming a plus 4. For this one we have to calculate the E naught value. Okay, right? So let's start now. So let me write down delta G1 is equal to delta G2 plus delta G3. Delta G is nothing but NF E naught is equal to minus NF E naught. I'll not be writing the E1 or N1, N2 or E2. So simply writing this one. Okay, Faraday is the constant value, cancels common term. N values are not the common factors. Anyways, let me convert all these negative quantities to positive quantities. Okay, answer remains the same. For the first one, 5 moles of electron into its E naught value. E naught value already they are given. It is a 1.51 volt. Okay, is equal to second equation delta G naught. 3 moles electrons required, for which you have to calculate E naught value, plus third equation number of moles are 2 electrons involved into its E naught value is equal to 1.23 volt. Okay, so we will carefully now simplify. 5 into 1.5 minus 2 into 1.23 is equal to 3 E naught. Okay, so this is equal to 7.55. This will be equal to 2.46. Therefore, finally we'll be having E naught value is equal to 7.55 minus 2.46 divided by 3, and this will be equal to 1.69 volt. Hope you understood. If you like the videos, please do share and subscribe, and thank you for watching. Have a nice day.